Okay, class, today we're going to cover the last section of chapter 5, which is about solving equations using the zero factor property. This whole entire chapter, we've been working on learning how to factor polynomials, and now we're going to understand why. Like, what's our end goal? So, friendly reminder that quadratic equations in one variable are written in the form ax squared plus bx plus c, okay? This is our standard form of a quadratic equation. And we're able to pull these apart, typically by finding the factors of a, c that add up to b, or by using one of our special factoring rules. The zero factor property says this. If I have a and b, let me open my pen. If I have a and b, and they're both numbers such that a times b equals 0, then either a has to be 0, b has to be 0, or both equal 0. Okay? And how do I use this to solve quadratics? Well, once I have a quadratic factored, I can take each factor and set it equal to 0 and solve for x. So if I have x plus 6 equals 0 and 2x minus 3 equals 0, I can solve for the possible values of x. And this is where my function is equal to 0. So this is where our graph of our parabola, because quadratics graph a parabola, that's where they cross the x-axis. So I can solve. So that gives me x equals negative 6. I add 3 to both sides. That gives me 2x equals 3. And now I divide both sides by 2. Let's make that look like more of a 2. So I have x equals 3 halves. These are my two possible solutions for this quadratic equation. So what I'm going to do in order to solve a quadratic equation by factoring is I'm going to write it in standard form. I'm going to factor it. I'm going to use the zero factor property to find x, which is the same as finding my solutions. And then I need to check my answers in the original polynomial. I need to do this always. So if I have 2x squared plus 3x equals 2, this isn't in standard form, so I need to move 2 to the other side. That gives me 2x squared plus 3x. I'm going to subtract 2 from both sides, and that gives me 0. Now I can factor by finding the factors of AC that add up to B. AC is negative 4 because A is 2, C is negative 2. B is 3. So some factors of negative 4 that add up to 3 could be negative 1 times positive 4. Negative 1 plus positive 4 add up to 3. Now I rewrite this middle term using these two factors. So I have 2x squared plus 4x minus 1x minus 2 equals 0. And now we factor by grouping. I'm going to put plus here. The greatest common factor of 2x squared and 4x is going to be 2x. So I have 2x times x plus 2. And the greatest common factor of negative 1x and negative 2x is going to be a negative 1. So that gives me a fully factored version of 2x minus 1 times x plus 2 equals 0. Now I can use the zero factor property to solve for x. If I have 2x minus 1 equals 0, and x plus 2 equals 0. I can solve each of these. I would get x equals negative 2, because I would subtract 2 from both sides. Remember, we're just trying to isolate our variable. Over here, I'd add 1 to both sides. That means I get 2x equals a positive 1. I divide both sides by 2. So I have x equals 1/2. So my two possible solutions are x equals 1/2 and x equals -2. Now I need to plug these back in order to check my solution. All right, so here are the two x values. We found positive 1/2 and -2. And we're going to go ahead and substitute these back into our original function in order to check whether the answers are true solutions of the polynomial. So let's start with everybody's favorite fraction. So if I have 2 times 1/2 squared plus 3 times 1/2, that's going to equal 2. And this is going to be a true statement if this is indeed a solution to this polynomial equation. So I have 2 times 1/2 squared, which gives me 1/4, plus 3 times 1/2 gives me 3/2 equals 2. I then also have that 2 times 1/4 is going to give me 2/4, which is 1/2. So I have 1/2 plus 3/2 equals 2. That gives me 4/2 equals 2. And 4 divided by 2 is 2, so this is a true statement. All right, so this is one of our solutions. Oops, sorry guys, I circled the wrong one. This is one of our solutions. Now I need to check when x equals -2. So I have 2 times -2 squared plus 3 times -2 equals a positive 2. -2 squared is going to give me a positive 4. Positive 4 times 2 gives me 8. There. 3 times -2 gives me a -6. So I have 8 minus 6 equals 2. That's going to result in a true statement. So therefore, both of these points are, both of these x values are solutions to this equation. So I could say our solution set is when x is equal to 1/2, comma, -2. Now typically I'd want to put these in numerical order, so the negative number should come first, and I'll try to remember to do that in future examples. But this is still a correct answer. All right, let's take a look at 4x squared equals 4 minus 1. I'm going to have to go ahead and get it in the standard form of ax squared plus bx plus c equals 0. So I'm going to subtract 4x and move it over here, and add 1 and move it. So I have 4x squared minus 4x plus 1 equals 0. Now I need to find the factors of 4, so AC is 4, that add up to -4. 4 could be -2 times -2, and -4 is -2 plus -2. So I can rewrite this middle term as -2x minus 2x. So I now have 4x squared minus 2x minus 2x plus 1 equals 0. And I need to go ahead and factor. I'm going to rewrite this as a positive, right? So 4x squared minus 2x, their greatest common factor is going to be 2x. That leaves me with 2x times 2x minus 1. Then here I have a -2x plus 1. But do we like a negative leading coefficient? The answer is no. So I'm going to pull out a factor of -1. That gives me -1 times 2x minus 1. I go ahead and collect my greatest common factors. That means I have 2x minus 1 times 2x minus 1 equals 0. Now this is an example of a perfect square, right? I have 2x minus 1 squared equals 0. That means both of these would give us the same value of x. So I only need to take 2x minus 1 equal to 0 once. So let's go ahead and make us some room. So I found that I have 2x minus 1 squared equals 0. So I'm going to take one of those, 2x minus 1, and set it equal to 0. I add 1 to both sides. I get 2x equals 1. I divide both sides by 2. I get x equals 1/2. Now, I need to check this into my polynomial. So I'm going to plug it in. 4 times 1/2 squared equals 4 times 1/2 minus 1. 4 times 1/2 squared, well 1/2 squared is 1/4. This would give me 4 over 2, right? Because I have 4 times 1/2 minus 1. Well, 4 times 1/4, those are going to cancel, right? So I would just get 1 equals 2. 4 divided by 2 is 2 minus 1. So I get 1 equals 1. Awesome. So our solution set is x is equal to 1/2. All right, let's try another example. I have 4x squared minus 20x equals 0. Oh no, I do not have 3 terms. Now I'm given 2 terms. What are my options? The first thing I always want to do, we remember this from our section 5.4 video, is pull out the greatest common factor. So what is the greatest common factor of 4x squared and negative 20x? Well, the greatest common factor of 4 and 20 is definitely going to be 4. And since I have an x squared and an x, the greatest common factor is going to be x. So this leaves me with 4x times x minus 5 equals 0. Now the 0 factor property still applies. I'm going to take 4x equal to 0 and x minus 5 equal to 0. I'm going to divide both sides of this equation by 4. So I have x equals 0. Very exciting. And then I'm going to go ahead and add 5 to both sides over here. So I have x equals a positive 5. I need to check both of these back in my original equation. 4 times 0 squared minus 20 times 0 equals 0. 0 squared is 0 times 4 is 0. Negative 20 times 0 is going to give me 0. I have 0 equals 0. Awesome. This is part of my solution set. So I have x equals 0. Now I need to check positive 5. If I take 4 times 5 squared minus 20 times 5, is that going to give me 0? Let's find out. 5 squared is 25. 4 times 25 is going to be 100. Minus 20 times 5, which is 100. So I have 0 equals 0. So this is also part of our solution set. So x is 0 or 5 in this case. Next, I have 3x squared minus 108. Okay, so the first thing I need to do is factor out the greatest common factor, which is a 3. Okay, so I'm going to take out a 3. That would give me 3 times x minus 2 minus 36 equals 0. Now this is a difference of squares, right? So I know from our rules this is going to factor to x plus 6 because it's x minus 36 and 36 is a perfect square times x minus 6 equals 0. So I have that I take I can ignore this constant, but I take x plus 6 equal to 0 and x minus 6 equal to 0. So I'm going to find that x is negative 6 and x is positive 6. And if you go through and check your answers, both of these are in our solution set. And remember, we check our answers by substituting negative 6 back in for x into our original equation. Next, I have 2x squared plus 5x minus 7, okay? So I need to find the factors of AC that add up to b. AC in this case is 2 times 7, negative 7, so that gives me a negative 14, and b is a positive 5. I could get negative 14 by taking a positive 7 times a negative 2, and then 7 plus negative 2 is going to give me 5. So I go ahead and pull this middle term apart, and then I can factor by grouping. So I have 2x squared plus 7x minus 2x minus 7 equals 0. Now I need to factor by grouping. We're going to write that as a positive. Oops, there's a positive in there, I swear. So I'm going to pull out the greatest common factor. 2x squared and 7x have an x in common. So that leaves me with x times 2x plus 7. And I have negative 2x and negative 7. Well, their greatest common factor is going to be a negative 1. So I pull out a factor of negative 1, and I'm left with 2x plus 7 equals 0. I collect the greatest common factors. I have x minus 1, and I have 2x plus 7 equals 0. So now I use the zero factor property, and I set each of these equal to 0. So I have x minus 1 equals 0, so I get x equals 1, and I have 2x plus 7 equals 0. So I subtract 7 from both sides. That's going to give me 2 times x equals negative 7. Divide both sides by 2. I have x equals negative 7 halves. Then you would need to do step 5, which is going to be check your answers. Oops. Check your answer. I believe this is our last example. So here I have negative x cubed plus x squared equals negative 6x. Okay, this definitely doesn't look like a degree 2 equation, but why don't we get all of our terms on one side, and then we can pull out the greatest common factor. So I'm going to add 6x to both sides. So I have negative x cubed plus x squared plus 6x equals 0. The greatest common factor of negative x cubed, x squared, and 6x is going to be an x. But do we like a negative leading coefficient? No. So we're going to pull out a negative x. That leaves me with x squared plus x plus 6. But I made a tiny mistake here, because when I pull out the negative x, that's going to change the sign on this and the sign here. So let's ignore that line and rewrite it as negative x times x squared minus x squared minus 6 equals 0. That looks a lot better. Now I can go ahead, and this is a degree 1. Now I can go ahead and factor this trinomial by finding the factors of AC that add up to B. AC in this case is going to be 1 times -6, so -6. And I need to think of some factors of -6 that add up to -1. Well, -6 could be -3 times 2. Because my leading coefficient is a 1, I'm able to use the shortcut that I can pull these apart so that I have x minus 3 and x plus 2. Keeping in mind that I did not forget our greatest common factor we pulled out. Now I would set each of these equal to 0. I have negative x equals 0, x minus 3 equals 0, and x plus 2 equals 0. So this time, instead of having 2x values, we have 3, and that kind of makes sense because we had a degree 3x. We'll talk about that more in later chapters. So I find that x equals 0, x equals a positive 3, and x equals a negative 2. And then it's up to you guys to complete step number 5 and check your answers.